Tom is snowboarding down a mountain, makes an angle of 53 degrees with the horizontal. Determine the acceleration if the coefficient of friction is 0.25. So we'll draw in the forces exerted on Tom. So we have the earth pulling down. We have the normal force perpendicular to the surface. The slope on Tom. And then we have friction opposing the motion here. So I'm going to draw in my axes. I'm going to call down the positive x direction and perpendicular to the surface. Positive y, I'm going to label my angle theta. I can do my vector components now, which I will draw in red. So part of that force of the earth is going to be perpendicular to the incline, which is going to be mg cosine theta. The part will be parallel, mg sine of theta. Okay, and then I'm going to set up Newton's second law horizontally and vertically, or I should say parallel to the axis, or parallel to the incline and perpendicular to the incline. So I'm going to have mg sine of theta minus our kinetic friction over the mass is equal to the acceleration. And then I'm going to have the normal force of the slope on Tom minus mg cosine theta is equal to 0 because it's not accelerating perpendicular to the incline. So we know the normal force will ultimately equal mg cosine theta. And we can substitute in. So we have mg sine of theta minus mu times mg cosine theta all over m is equal to a. I have an m in each term, so that'll divide out. I'm left with g sine theta minus mu g cosine theta. So this is going to be g times 0.8 minus 0.25 times g times cosine of 53 is going to be 0.6